part of building your software to be ready for agents to help is going to be good observability, because observability feeds its context, right? It feeds what it can know. And if you've got boundaries around, okay, the error rate has increased, and what people do in this situation is go look at the traces until they find a service that's failing more than normal. Mm-hmm. And the first thing they're going to do is restart that service. And the second thing they're going to do is look for a recent change in that service and roll it back.
Yep.
And if that's always what people do, and I think that's pretty common, an agent could identify the service that's failing, identify changes. It could do that rollback while contacting people. And so then the people start out a little bit more ahead of knowing whether the rollback helped.
Yes, more like this, let's say, agent on call. So the agent is observing the system. He's able to see all the data from the observability tools. Maybe there are some error rates popping up, and he was trained to now take the decision, okay, I could try to solve it with just a restart. That's based on old incident data. That's based on all the experience from my team, and they teach me as an AI agent to do it, exactly that. But again, as I'm on call, I will inform my team that I did exactly that one time, not like multiple times over and over again.
Yes, don't do this on a 10-second loop and try different things every 10 seconds. That's going to be chaos. The bad kind.
Absolutely. and now you mentioned chaos, and now let's zoom in exactly that topic. Why? Because you mentioned some seconds ago, you need to know what normal looks like. So if there is like a service getting out of control, you need to exactly know let's say on a Tuesday at 10 a.m., this is normal for this service because the traffic is going up for whatever reason. But this knowledge needs to be also not only part of your teams, of your experts that are building those software, it also needs to be part of the agent. And how should you train it? How should you teach and educate an agent how he should react? You need to put him in not normal conditions. And the best way to do it, from my perspective, is to introduce some chaos, to really change the system in a very controlled way, to really, inject some errors in the system so that the human can detect if the agent is now doing the right steps.
Right. So the question of whether agents are going to be useful, whether you want to put them on call in production, is going to be answered potentially by chaos engineering experiments. Of while we're sitting here watching it, does it screw it up?
Correct. And you need to do it in a proactive approach. It's not like a good idea to install the agent, go into production,
and then wait for an incident.
Exactly.
And then the incident comes and you're like, oh, crap. That agent just did something. Oh, right. We turned that on. What were we thinking?
Yeah. How to shut it up? How to shut it down?
How do we turn it down?
Yeah. And now the agent is restarting all his friends because they're all on call now. That's where it's getting complicated. And that's, you need to be prepared for those moments even more now with this new way of building systems.
Yeah, because you need to test, does it react appropriately?
Yeah.
And then does it stop when it should?
Absolutely. And something we have created at SteadyBit is, of course, you can run those experiments in a running system. But now there's a ton of data coming out of those executions and tests and all that stuff. It's at some level very hard to figure out what is like the root cause and how could I solve it. And that's, for me, a strong use case to then use this data in combination with observability data to really identify with AI help what was going on here. What is like the root cause? How should I address this issue?